I've updated the floating point binary to decimal converter. So if you go to the resources section and you open up the file, and you can press the button in the top left hand corner, FTD, so there it is up here, and you'll see you've got access to the converter. Now you see that I've got extra content here, and I've put this in order for you to see how all of the conversions actually been completed. So let's say, for example, we look at some special cases. So let's say the special case, well at the moment it's just 0, so the output is 0 and it's a denormal, and you can see it's actually a denormal plus 0 because the 0 here is positive. When I click there you'll see it goes minus 0, but I'm not bothering about the plus minus 0. The final answer at the bottom here I'll just put in as a value of 0. So let's have a look at some of the others. Let's say these are all 1s. So if these are all 1s, then we're going to get plus infinity, and you can see that's the 255 minus 127, that's 128, and that's a special case, it's plus infinity, and you'll get the minus infinity as well. You can also get the QNAN here at 128, and also get the SNAN. So those are the special cases. Now if we were to look at, for example, the denormal values, so the denormal, all of these are exponents are at 0, and if we click on one of these you'll see it's going to give us the exponent here, in this case it's 0, so the denormal value for that exponent is minus 126. So we've got the mantissa copied here, and we've got the value 2 to the power of minus 1, because that's what this value here is 2 to the power of minus 1. So if I put the next one in, you're going to get it plus 2 to the power of minus 2, and that would go up to 0.75. So it allows you to see the values here for the mantissa and how they're actually generated. So whenever we've looked at the mantissa, it gives you the actual value of the mantissa, so that's 2 to the power of minus 1, which is a half, and the result then is going to be the sign bit. So the sign bit is going to be given by the first bit, so it's 1 at the moment because it's positive. If I change that, you'll see it goes to minus 1. And then we've got the mantissa, and this is the mantissa here, 0.5, and then we've got the exponent, which is 2 to the power of minus 126. So if we were to go and look at the normal values, you'll see if we pick on, say, an example here, and you'll see here we've got the exponent bit, which is the 1 for the normal value, and it's going to be 2 to the power of, in this case here, we've got the first one, so it's 2 to the power of minus 2, that's the second one here. So that's equal to, in total, 1.25. And you can see here, you get the result from this. It's going to be the sign here, which is the positive, times the 1.25, times 2 to the power of the exponent, which is the normalized exponent, which is the biased exponent, sorry, which is a value of 2. So again, you could add the values in here, say 1, 1, and you'll see that this here gradually gets closer and closer to a value of 5.2 as we add each of the values in. But you can see here also as well that this is an approximation, and the final two values we're adding in are 2 to the power 20 and 2 to the power 20 minus 21, and that's heading towards the value of 5.2. There's actually a mistake there, it should be this one and this one. So it's heading towards the value of 5.2. So it's quite handy, and if you can press clear, it'll clear off and you can start again. So you can see each of these changing instantly as you work through, and playing about with this is really good for giving you an intuition as to how your floating point binary to decimal actually converts. So I suggest you download that and have a little play with it, and you can have a look at the code as well. That's all for this video. Thank you for watching. I'll get you in the next video. Goodbye.